In these questions, we're going to be completing nuclear equations. The rule for completing nuclear equations is that the sum of the atomic numbers is constant and the sum of the mass numbers is constant. So in our nuclear equations, the total mass number in the reactants must equal the total mass number of the products, and the total atomic number in the reactants must equal the total atomic number in the products. So in this question, in our reactants, we have polonium, 84 atomic number and 181 mass number. That's the only thing on our reactant side of the equation. So our sum or our total is going to be 181 for the mass number and 84 for the atomic number. And then in our products, we have this unknown nucleus. I'm going to say the mass number is M and the atomic number is A. And we have an alpha particle with a mass number of 4 and an atomic number of 2. So I'm going to add those together in my products. So for the mass, it's going to be M plus 4. For the atomic number, it's going to be A plus 2. And I know my mass is conserved in the reactants and the products, so those are going to be equal. And I know my atomic number is going to be the same in the reactants and products, so those are going to be equal. So to solve for my mass number, I'm going to have to do 181 minus 4, which is 177. And for my atomic number, I'm going to have to do 84 minus 2, which is 82. So I found my atomic number and mass number of my unknown nucleus. So we can fill those in here. We had 82 for our atomic number and 177 for our mass number. Next, we need to figure out what is the symbol and name of our nucleus. So the atomic number is 82. Let's head to our reference sheet. Here's the periodic table, and we're looking for the element with atomic number 82. And here it is. It's lead, which has a symbol Pb. So we know this is going to be lead. So there's our complete nuclear equation. Finally, what is the name of the unknown atom? Well, we know that it's lead. And as for the number here, that's going to be the mass number. Since lead always has an atomic number of 82, we add the mass number at the end so that the name can give all the same information as the nuclear symbol. Awesome. Let's do one more of this type. So in this nuclear equation, we start with our unknown nucleus. So I'm going to again call it M for the mass number and A for the atomic number. And then we're adding our alpha particle, which has 4 for the mass number and 2 for the atomic number. So in our reactants, we have M plus 4. And in our reactants for the atomic number, we have A plus 2. Then for our products, we've got, for this nucleus, 87 mass and 43 atomic. For this nucleus, 128 mass and 52 atomic. And we've got 3 neutrons, which have 1 for the mass and 0 for the atomic number. So we want to go ahead and add up all the mass numbers here in our products. So it's going to be 87 plus 128 plus 3 times 1, which is just 3. Then for our atomic numbers, we've got 43 plus 52 plus 0. Okay, I'm going to go ahead and add all those up. For the mass, we have 218. And for the atomic number, we have 95. So now we can go ahead and solve those equations to find our unknown mass and atomic number. So our mass number is going to be 218 minus 4, which gets us 214. And our atomic number is going to be 95 minus 2, which gets us 93. So we can go ahead and fill that in here. Our mass number is 214. Our atomic number is 93. Then we need to head to our periodic table to figure out which element we have. So we're looking for atomic number 93, and here it is down here. 93 is Np neptunium. So we can go ahead and fill in our symbol here. It's going to be Np, and our name of our unknown atom is going to be neptunium. And the number we add here again is the mass number, so 214. So we had neptunium 214. So you can see in these questions, all we're doing is looking at the top row, which is the mass number, and making sure that the reactants and the products all have the same sum. And we're doing the same for the atomic number, which is the bottom row.